Hello everyone, I am Dhanasekhar S, Assistant Professor, Department of Computer Science and Engineering, Shriram Engineering College. So, today we discuss about graph theory. The points are discussed: path, cycles, and trails or walks, subgraphs, representation of graph, and isomorphic of graph. In this session, we will continue our exploration of graph theory by focusing on some very important and fundamental concepts that are essential for problem solving and advanced applications. These concepts are very important not only for university examination but also for real world applications in computer networks, algorithms, data structures, and artificial intelligence. By the end of this session, you will clearly understand the theoretical concepts along with examples and problem solving techniques. Next, move to next slide, path and cycles. Now we are going to talk about two fundamental structures that appear in almost every graph problem, path and cycles. So what is a path? A path is one of the simplest ideas in graph theory. It is a sequence of vertices where two important things are true. Every two consecutive vertices in the sequence are connected by an edges. Second one, all the vertices in the sequence are different. That means you never visit the same vertex twice. Example, look at the slide. Consider this graph, vertex A, vertex D, and C, B, and E is a path. Again I repeat, the vertex A and then vertex D. So we travel from vertex A to B and A to D and D to C, C to B, and B to E is a path. So in this path, we never visit the same vertex twice. So all the vertices are different. So A to D and D to C and D to B and B to E. So all the vertices are different. So never repeated again. So consider another one path. We travel from vertex A to B and B to E, E to D, D to C, and C to B, B to E, and E to D. This is not a path. The reason because we visit some vertex more than one times. So we appear or we visit the vertex B in two times, the vertex E in twice, and vertex T in two times. So when you repeat the vertex, it is no longer called path. It has a different name. So next, walk. The walk is a more general idea. In a walk, you can revisit the vertices and even revisit the edges. A path is a walk that never repeat vertex. All paths are walks but not All walks are path. And next, what is cycle? The definition of cycle is a closed path. Closed means the starting vertex and ending vertex are same. Consider the example. The starting vertex is A and ending vertex is A. In this path, we have terminal vertex are same. So this type of path is called cycle. So from A to D and D to C, C to B, B to E, again E to A. So the terminal vertices are same. This is called cycle. So in cycle we have some rules. Have at least 3 vertices. Not repeated any vertex except the first and last, which are the same. And next move to subgraph. Now that we know what is a full graph looks like, let us talk about taking its apart. This is bring us to the idea of subgraph. So what is definition of subgraph? A subgraph is exactly what it sounds like, a graph that lives inside another graph. Formally, if we have a graph G, then a graph H is a subgraph of G if H is contained entirely within G. So we consider 2 points. The first point, every vertex in graph H must also be a vertex in G. We denoted this as V vertex set of H is properly subset of vertex set of graph G, and edge set of subgraph H is a properly subset of edge set of graph G. And the second rule is sorry, there is a third point. This is a hidden point. The assignment of endpoints to edges in H is the same in the original graph G. This means you cannot redefine the connections. If an edge connect the vertex X to vertex Y in graph G and that same edge is in graph H, it must still connect X to Y in H. Next one, the example of subgraph. So this is some original graph, capital G. From this original graph, we construct 3 more subgraphs. Graph H1 is one subgraph, H2 is another one subgraph, H3 is a third type of subgraph. So at minimum, at least one subgraph is there is a one and at least one subgraph in each and every subgraph. So consider the subgraph H1 C and D that contains 2 vertices and 1 edges. So where here C and D, this part Next one, subgraph H2. So consider as this point, vertex A to B, B to E, E to D, and D to A. This part is a subgraph of the graph character G. Similarly, third one, the next one, we have learned about path and how to travel through the graph. Now let us use that idea to answer very important question. Is a graph is all in one piece, or it is a broken into separate part? This is concept or connected or disconnected graph. Yeah, graph is a connected if you can travel from any vertex to any other vertex in the graph. The formal definition to say there exists at least one path between every pair of vertices. The definition of disconnected graph: a graph is disconnected if it is not connected. This means there is at least one pair of vertices that have no path between them. The graph is broken into separate pieces with no way to get from one piece to another. So consider the following graphs. We have three graphs, H1, H2, H3, and each has the graph H1 have two vertices, graph H2 has a four vertices, and H3 have five vertices. So consider the graph H1. The two vertices are directly connected. So this graph is a connected graph. So another one, H2, consider H2. The vertex A, B, E, D, all the vertices are connected to each other. So this graph is connected. Consider the graph H3. So this graph is a disconnected graph. There is no way to connect the vertex A to B, or vertex A to C, or the vertex A to D. Similarly, E to B, E to C, and E to D. There is no edge from this part to that part. So this is an example for disconnected graph. Thank you.